without further ado, I guess we're ready for our next speaker. So we have with us Artem Manchenkov. He's a software engineer at Microsoft, over a decade of experience and with the design and development of complex distributed systems. Artem, the stage is yours.
1, 2, 1, 2. Hello, everyone. Really excited to be here and to see so many people. So, my name is Artem. It's really nice to meet you. And today, since software architecture is a huge topic, and it's not possible to cover even in the whole conference, the all possible ways of software architecture and the way of working with the software, I will be getting to the very small amount of information, which is specification-driven development. And I would like to change the slides. Thank you. So this is very weird topic because specification-driven development sometimes works, sometimes doesn't. And we will try to answer this question, why does it happen? So I will start with a brief introduction about myself, just to confirm that I have some kind of expertise in this topic. I have over a decade of experience in all of the kinds of software development, starting from game dev to mobile applications and also microservices and web development in general. And this is the most of my time in this industry. In web development, this is very important for the specifications because usually specifications, it's about communication with others just to explain how something should work, right? So I also try to spend some time on open source, and I also recommend to do that to you. And I consider myself as technical diversity advocate, so I encourage people not only try to contribute to open source, but also try to work with different languages, work with different frameworks, and try different technologies in your daily basis. Because it's very, very bad situation that so many engineers are basically stuck in one framework or in one language, and then they don't have this opportunity to get another perspective of what's going on in a different world. People work with Java, but they don't know how Python works in other industry like AI, which now is everywhere. So yeah, that's about me, long story short. And what's about this topic? We will not be talking about the code itself, because it's actually irrelevant to the software architecture. Software architecture is a more high-level topic, and you have to work with this even without knowledge of any language. And there might be some cases when some software architects worked with actual programming long time ago, and they don't need to know any language at some point just to design software architecture, because it's about different things. So this talk will be about specifications that at some point actually changed my developer mindset. And that's what I want to do with you, change your mindset about software architecture and specifications. Of course, we have several bullet points that is for you. It's about what to expect from this talk. First of all, I will give a brief introduction into the specifications world, in case you never worked with it and you never ask yourself what is a specification in the engineering world. Then we will try to cover some general software development problems which actually might occur even further in not only in software architecture, but in software development, and then the implementation, deployment, support, maintenance, and all that stages of the software. I will try to suggest specifications as a solution, and you will see some examples based on my experience and based on experience of other companies, other engineers, how specification actually might solve these software development problems. And the main question for everyone is, what can I get from it? Because if there is something and I don't see the point of usage it, then there is no benefit for me. And I will try to show some benefit, of course, and I think you will be interested in the specifications after all. So, of course, there are some recommendations from my side, which I collected through all the times I was working on the different software. So I will try to give you some hints how to start to improve your development processes and software architecture and design processes even today. So let's start with the specifications. That's a very huge topic as well, and we have many definitions of the specifications. But in software engineering, there is a particular definition or explanation of what is the specification. So I want to ask you, but don't answer this question. Please raise your hand if you think or if you feel that you pretty good understand what specification is in the development perspective. All right, that's a little bit worse than I expected, but that's the main point. That's why we're here, that's why we're discussing this topic. But before I will tell you what the specification is from the developer perspective, I also decided to double check myself just to make sure that I also understand what specification is. And I found this a really interesting quote on the internet, that software engineering is the art of turning specifications into miracles. And I really like this one because it tells us that specification allows us to do even more than just software. It's a miracle. 50 years ago, we couldn't imagine that we will have smartwatch on my wrist and I could call anybody just in a couple of seconds. And even the AI, not 50, but even 10 years ago, it was something that we couldn't comprehend. And now we have it everywhere, and that's basically a miracle. We just get used to it. And everything started with the specifications at some point. But actual definition, which I found in Oxford Dictionary, which I trust really good, that specification is a detailed description of the design and materials used to make something. And I want to draw your attention to this make word in this sentence, because specification doesn't describe how something works. It doesn't describe what should you expect from anything. It describes how to make it. So basically, we have some introduction that allows us to think that, specification is just the beginning of something where we collect all the things we will be using to create something bigger. And that's how we work. With that information, we can go further and see some examples of specifications in software development, in software architecture. There are a lot of types and even subtypes of them. Because the general idea of software starts with some design document. Let's say there is an architect, or there is a manager, or there is a customer, and they come with idea. Based on this idea, we create some prototype, maybe even just one-pager or six-pager document where we describe what will be the solution, what we will use to create this software. And that's basically the first example of the specification. Of course, it's not that clear, and it's not for all engineers. We cannot create software architecture just from one document which was written by some non-technical person, because we have to convert it to a more understandable way for engineers and to make software architecture out of it. That's why we have another example, UML diagrams. Basically, we can describe what is the software and how to make it. We define all the classes, we define all the interactions between them, we define all this information just to make this specification more understandable for engineering world. And we don't describe how it works, again, we describe how it will be made. Then we have OpenAPI, which is a well-known specification in web development. If you have microservices or server-client communication, then OpenAPI is your friend. And I will also talk about this a little bit later, but I believe that this is the main point where something went wrong. And moreover, we have clouds everywhere, we have infrastructure as a code. So basically, this is an example of another specification. We define all these configurations, resources, then we do something. And out of these specifications, we have the whole cloud. we have all our architecture based on just one YAML or even other text documents, which is not even the software. So that's how specifications can be powerful in the software engineering world. I also like another example, which is gRPC. And I hope that with this technology, you're more familiar with the specification itself. And please raise your hand if gRPC and OpenAPI makes some sense for you. OK, yeah, we see much more hands. Yeah, thank you. Now we're good. So gRPC is very similar to OpenAPI from one point of view, because it's also the specification for developing some services, especially microservices, because it works really well with it. But there are some differences which we will cover in a minute or so. But gRPC is the next level. It's an example of when something went good, not wrong. But there are some specifications which I really don't like as an engineer, but I have to work with them. For example, troubleshooting guide. It's a nightmare for engineers. Because if something happens with your production system or with your software, with anything in technical world, then troubleshooting guide kind of should help you, but it's actually a thing that we hate because we have to write them as well. And troubleshooting guide, I see the question in your head, like, how does it help? What does it make? It makes nothing, of course, but it makes you to fix your production. So specification actually, again, contains something to make something. So in our case, troubleshooting guides is not that useful for software development, but it is useful for software architecture and thinking about your product in advance. And even method signature could be a specification. In a Java interface, you have some definition of the method, you have arguments, which are materials, and you have method itself, which is a design of how this software will work. So with that, we're moving forward to OpenAPI, which I mentioned previously. And I really like this specification, and I used it so much and so many times in so many different projects. And basically, it's just one YAML document where you can describe some endpoints of your service, you can describe the methods of working with these endpoints, and all the data contracts, like what kind of data you expect from your client, what kind of data will be returned to your client, how it should work with the authentication on your server, and many, many more things. It's actually quite excessive specification. And you can define almost everything for your API there, but initially it was supposed to work with all these things mentioned in the list. We should define all our requirements. That's how it's supposed to work. Because you cannot write a specification if you don't have requirements of your system. Then you have to understand the complete design of your system to make an API properly. Then we have all the configurations, authentication, what kind of errors we have, what kind of servers we have. Is it HTTP or HTTPS, even though it's not a question anymore. But anyway, all these stages that we should use with OpenAPI actually kind of disappeared. And now we have a little bit different picture of working with OpenAPI, because it's just the specifications, which we usually generate from existing code. But we don't create it in advance. And that's the main pain point in the spec-driven development. So, of course, we don't have testing, publishing, and deployment of these specifications, because now they are kind of part of our service. So, the main question here, how does it help with development? How does it help with software architecture? And how does it help me as an engineer? And the answer to this question is really, really simple. It doesn't. Specification makes no sense if you don't use it. And specification makes no sense if you generate it from your code. Because that's the main point of the specification. You should describe how to make something. And if you make specification from the already built and deployed project, then of course it doesn't help. So now we have this problem that specifications, which were supposed to change our engineering world, actually were just forgotten. But I mentioned gRPC as well, and that's the specification I like. So why? The main difference between OpenAPI and gRPC from the specifications perspective is that gRPC cannot be generated after your code is implemented, unlike OpenAPI. So the main pain point here is that engineers are blocked and they cannot work on product if they don't have gRPC specification. And that's the main benefit of it. So we have blocked and angry engineers, but now we have problems solved. So now we have to choose. Do we want to work with happy engineers and bad product, or we want to work with good product, but good engineers, but angry engineers? So the enforcement is the key. And basically, if you have your specifications with some kind of enforcement, then basically it will help. And we will come to specification first approach, which is also specification-driven development pattern. Now we can see that if we work with gRPC, we first define all the models, all the schemas, and then we generate our code, both for client, for server, and for anyone who are interested in our service and communication with our service. So now we solve one problem. And the best scenario of working with the specification first approach should be something like this. We start with a specification, then we already can prepare test cases or business scenarios based on just one single specification. And it's not only for engineers, it's for general process. When you design your software, you should understand what's the main purpose of this software, how to test it. So there are some business scenarios even before you write specification. But now you can even test it. Then we can work on server and client implementation at the same time. We don't have to wait to implement some server and then generate the specification out of it. We can write specification and say, hey, backend team, please write this server. And hey, frontend team, please write this client. This is the specifications that you should stick to. And you don't have all these inconsistencies and blocking processes. After that, we assume that we run some tests. We assume, right? So we test our product somehow. It doesn't matter. But once we have the results of these tests, we can do some minor, I hope that it would be minor adjustments to our product. We update specification if needed, and everybody is synced up. We are done, we can deploy, and we are happy. That's the best scenario. What I should say now? I don't think that it's a case for a lot of people. And please raise your hand if it sounds like your case in software development. If you ever worked with this scenario and you had everything perfectly done. Thank you. That's exactly the main problem of software architecture. We don't do it in a proper way. And of course, you might be thinking like, yeah, you know, it doesn't work, it's not that easy. Yes, it's not that easy. It's very difficult to reach this point. And that's why OpenAPI failed in this point. They couldn't achieve this quality of this process. So right now we have more realistic example, how we work. I hope that it's not the case for everyone, but it's more realistic situation. There is some initial meeting where you have a lot of people from tech and non-tech industry. They discuss some idea, project, implementation, whatever. Then basically you collect this information from the meeting and you start working on the design document where you start thinking about software architecture, what it should be, how we should represent it, how it should work. And you start thinking about technical details and you miss the main point of business scenarios and you miss the main point of the consistency of these APIs and who will be the consumer, the client, and how to organize the development process efficiently. So we have blocked engineers because OpenAPI specification will appear only after server is done, and the client might work with some kind of a verbal agreements that, hey, you should do this, and they will do that. But once specification is there are some inconsistencies, and they have to adjust already completed front-end project, let's say, for your backend implementation or different microservices. After that, hopefully there will be some tests, but usually there are no tests. And we assume that we're done, but you already see what's under on the second half of this slide. We have to validate it. Probably we will have some fixes, issues, bugs. Then we have to go back, update everything. Since specification is not the main sync point, we run into some inconsistencies. And we have several problems with these processes. First of all, the main and the largest issue there is contracts inconsistency. It might be very minor. Let's say in front end they use snake case, in back end they use Pascal case. It's just the name of the variable, but if it's not validated in the response, then you have this problem. So you assume that all your teams can work together. You assume that all the engineers are happy to discuss the contracts and establish the software architecture through the whole company, but they are not, and they will never be, because that's not the main part of engineering job. Engineering job is to create product, not to sync with all the company 500 engineers on some specific standards. That's why we have specifications to solve this problem. Another thing is maintenance cost, because if you have all this manual effort to work with your software, then everything will be much more expensive from costs of any kind. Engineering time, engineering force, I don't know, infrastructure costs, and all other costs that you involve into software development process. So we have blocked engineers, as I mentioned. Front-end cannot work efficiently without backend implemented. Even though you can assign the task to your backend engineers to write the specifications, but they will anyway implement the software first and they will regenerate the specifications. So it doesn't make any sense to introduce it that way. So time to market is worse, because you cannot easily just change something in the specification, everybody will be regenerated automatically and you are done. No, you have to spend a lot of time. And that's basically blocking your product from going to production really soon. And I really care about developer experience, and I encourage everybody to care about this. Because developer experience is about how happy your engineers are, how good your development processes are, and basically if you have proper environment, everything will be done much faster, especially with the specification. And ease of changes, if you don't have specifications, it's just more complicated. I'm not saying that it's too complicated. You still can work, you still can create any product, and you can solve any problem, but it's just more complicated in general. So what is the solution to all of these pain points and how we should actually work? And the answer again is very simple, and I think you already know actually. We should just do not write code without any specification. Sounds good. Now we can easily change our development processes, we can start with the specification and then we're done. Basically, that's how it should end. But in reality, of course, there are more things to discuss. Industry, that's the main thing. We don't do anything what is not approved by the industry. And it makes sense, of course. There are a lot of examples of many popular products and projects like Django from Python world or Azure Function from Azure Cloud. All of them suggest the same solution. Please write the code and then generate OpenAPI from it. And it happens with all other specifications as well, except gRPC, because they couldn't do that, and they cannot do the same even now. But with OpenAPI, it's easy, because everybody will follow. So they decided that, yeah, all right, that's easy, let's do. let's do it that way. And basically, whenever you go, if you are, let's say, entry-level engineer, and you just want to learn how it's supposed to be, you will learn this. And instead of thinking properly about specifications, you will understand that, all right, specification is the thing that we generate from code. So right now, we should say that specification first failed and code first won. But is it true? Not really. I thought that for a long time, actually, until I found really interesting package which was named Go Swagger. Back then, I was working with Golang services, and I had to create like several, I would just say, dozens of microservices in Golang, and I really hated the process because in order to create this microservice, you have to write a lot of boilerplate code, especially if you have to do that 30 times a day. And the whole infrastructure was the same. I would just need copy paste the same repository with some minor changes. So it was just the boilerplate. And I realized that, hey, actually, they use the same specification as a result. And there is a package Go Swagger that can generate the whole microservice out of one YAML file with 30 lines. I said, okay, let's try. And I incorporated this package into our project, and I was able to generate 100 microservices in less than 1 day. And basically, the whole architecture of these services were very easy. One database, one endpoint with health check, one endpoint with metrics, but it's not the main point. The main point that I achieved this kind of results in just 1 day after spending several hours of learning this package. So it allows you to generate client SDK, server stubs, some tests, and it supports custom templates. If there is not enough files, you can just write your own thing, and it will generate whatever you want, any complexity of the file, because it's just template engine. The only problem was that it worked only with OpenAPI version 2, which is already deprecated, and now we have third version or 3.1.2, not sure. Anyway, it's not the best example, but it was something. So this is how specification actually helped with the development. It reduced my effort, I don't know how many times. But it was actually a successful experience. And now we should answer another question. Is there something else, right? One example is good, but what about others? What about not Golang projects and other different languages? And of course there is. There are a lot of packages, and I actually realized that even official package was developed like 10 years ago by Swagger company, which were authors of OpenAPI previously named Swagger. So they did it actually 10 years ago, and nobody listened to them, nobody used that, but it's a really good project. Now we have even community package, which has more wide support, with more languages, with more SDKs, with more frameworks. You can easily generate the project for Java, Python, PHP, C#, Go, and other languages in a couple of hours, let's say, maybe days as a beginning. And the only problem here is that it's written in Java, so if you're not a Java expert or you don't have Java experience, it might take a while to get familiar with all this tooling and to set up it properly. Now, I want to highlight another specification, because I talked too much about OpenAPI, but it's not it. There is also Async API, which is supposed to solve the problem about asynchronous communication. OpenAPI, all right, it's about HTTP endpoints or something very basic. Async API allows you to generate the same stuff for your Kafka, RabbitMQ, any queue, and any message broker you have in your infrastructure. So it actually solves another problem for software architecture. Now we can generate not only microservices, but now we can generate some handlers for our data pipelines. Now we can generate the whole message queues without using this particular architecture with HTTP or gRPC. And you can also extend it. It's quite new product, less than 10 years, so it's new. And you can extend it easily as well. You can create your own templates. You can generate different classes in different languages. And it evolves even right now. First time I checked this project was like 4 years ago. Last time I checked was yesterday. And the difference is huge. Besides, if you don't like writing Open API or Async API, there is a type spec. This is more convenient language and the specification created by Microsoft to write different reusable models, schemas, and now you can generate Open API, Async API, gRPC schemas out of this type spec. So it's even further step into specifications development. So you have specification to generate specification. Isn't that great, right? So a lot of templates can be also introduced here. But specification is not only about creating software. It's also about working with the software. There is a company named Cerbus, and they created open source product which helps you with authentication and authorization in the different cloud environments, or if you have on-prem, you can also set up this open source there just to handle all this really difficult process of authorization for your users. And basically, let's see how they define these roles. They use specification. Perfect example that it's not only about code generation, it's also about how to think about your product. Because if your customer is an engineer, just provide the example of the specification and they will do everything perfectly. So we have much more interesting in open source world. You just need to know what you are looking for. There are some examples of other packages, and one of them was even created by me because back then I didn't know that it's that easy, so I thought, oh, I will create the perfect package. No, I didn't, but anyway, it's there, so you can try all of them. There will be a link at the end of the presentation, and I believe that this is just the beginning. Yes, it was created a long time ago. Yes, specifications are not perfect, but now we are limited just by our imagination. Now it's Async API, type spec, Open API, maybe gRPC, but what if tomorrow there will be some other company that will create specification for metrics API, and which will define Prometheus configurations and all these counters, which will help infrastructure engineers, SREs, to generate thousands of checkers, thousands of lines of codes to work with these counters. Everything could be possible with just one specification. Another example, storage APIs. We have Azure Blob Storage, we have AWS S3, we have Minio, we have a lot of different storage providers. But what if we can define all of them in one specification and it will be compatible with all the products? Will it help? I think so. We can generate code for any platform out of one specification. And same thing with data API. Yeah, this one is more complicated because the data is not yet established, let's say, in our world. And we have a lot of ways of working with it. But in example of Elasticsearch, it's more or less stable. So you can define all your indices in the specification instead of writing this code and then press one command and everything is deployed. You have to migrate to another cluster? Yes, you can do that. And we actually did that. In my previous company, we covered almost everything out of it with the specification. And I have to say that developer experience was just amazing. We were able to develop our services in a matter of hours instead of weeks or months. We were able to show the result without even writing a single line of code because everything was in the specification. So you can just show the specification to describe how it will work and how you will make it. That's the main thing. And yeah, I forgot about this one, but in Data Lake, you can also define your data flows. So besides these specifications, now we have AI. And you can use this AI to help you with either writing specifications, which is even better. You don't even need to write specifications. Just write a comment how it should work or how it should look like, and then adjust. I do that all the time. So we can also leverage AI in code generation. You can teach some model, this is my specification, this is the code I want to get. Help me. And it will help after some learning process. And the main thing for you, as people who don't use this approach, what's the impact and what's the benefit which you get from this specification if you have to migrate to this? I would say that first of all, you have better quality assurance for all of your products, because you can validate business scenarios. You can work with the actual test cases without engineers started working. You have better understanding at the beginning of your product creation, because if something doesn't work with the specification, it will not work with the actual implementation. Then we have happy engineers. Developer experience is better. The amount of time we spend for writing code is less. And anyway, some automation every time makes engineer happy. We have faster development as a coincidence because of the previous points. We just do less, and that's why we have faster development. I'm not saying that it's easier, but it's faster. We have fewer number of errors because we don't have these contracts inconsistencies, we don't have delays in processes, we don't have human factor, we don't have a lot of things that we have right now. And that's actually proved point. And we have less communication overhead. It's not that huge benefit, but if your engineers are struggling with communication overhead, they might solve a lot of problems and increase the overall environment in the engineering department. And of course, we have less code, because if we can generate something from the specifications, we don't need to commit it to our repositories. And actually, some of companies which I helped to migrate to this process saved terabytes of data annually, just by reducing the code which was written manually with the code which is generated during build or release pipeline. And that's huge difference, and in the cost perspective as well, because you don't need to buy this amount of storage. And since specification allows you to generate one single project, you can define the structure of this project, which will be unified across your organization. So you don't have these problems when new joiner comes to some team and they have one infrastructure or architecture of their software. Then they do some collaboration with another team and they have completely different architecture. So you have to always learn, why did you do this, or why did we use this product? With specification, you have unified structure and you can just add more modules, but they will be in the same manner. So it's not that ideal, because of course there are some compromise on the other hand. We have language specific. I never saw all these tools for all languages. There is always either Java or Golang or PHP or something which was very established in the industry. But for example, for Rust, it's quite tough to find anything for specification. So you have to combine several languages to work with this approach. It's a bit tough to refactor because you have to consider a lot of things that one specification can change hundreds of lines of your microservices or architecture in general. So you have to be careful, and it's just more complicated process. We have some compatibility issues because, as I said, Ghostwagger worked with the second version, but never worked with the third one, even after many years of creating issues on their GitHub. So you have to keep in mind that there are some limitations in these specifications. You cannot describe anything which is not related to the actual specification scope. So if we use an open API, it's only about HTTP communication. If we use async API, you cannot provide authentication details of your server. So there are some limitations that we should keep in mind. And it's just the template engine. It's not a rocket science. It was just done by some company, and now we have a lot of different examples. So my personal recommendations about starting using this particular approach are the following. First of all, if you have huge monolithic service or your software architecture right now looks like huge company, which was, I don't know, which have been developing software for more than 10 years, and now you have to work with this project, please don't try to integrate it into this particular case. Because it works well if you have small service or maybe new project which is not yet developed that much. And you can feel all the pain points, you can collect all the feedback, you can experiment, and it will not affect your production or your software. Another one, try to stick to open source. There are so many great projects that can be used, which I didn't know earlier, but now I know, now I recommend. Because you can save a lot of time by doing that. Try to automate it as much as possible. Don't rely on manual work, because it will be just ignored and skipped. Care about your developers and their experience. If something working is well for them, then probably it will work for your company. And try to enforce it, because we remember that's the key difference between OpenAPI and gRPC, and gRPC succeeded in it. So done is better than perfect. That's the principle I follow for last 5 years, and it always helps me to write better things, create better software, and use more interesting solutions. There are some resources I mentioned during the talk. You can find it later, and if you have any questions, I'm here to reply. Thank you.
Do we have any questions from the audience? Point? No?
No.
What's your favorite combination of technologies in using the generator?
I cannot tell.
Yeah.
Because I have my personal favorites, but now I have my work favorites. And they are different. So
Fair enough.
if I don't want to, let's say if I have my pet project, my perfect combination will be Python with something.
Okay.
If I tell my to my coworkers that it's my favorite, then yeah, it doesn't sound good. We have to use more .NET related tools, I would say.
Okay.
So yeah.
How's the landscape on that technology in terms of generating code?
On one of the slides, there was mentioning about the Azure stuff, which follows actually the bad way, and we are working on the improving this part as well.
Okay.
Hopefully, at one day.
Yeah. Oh, me too. That's the area that I prefer as well. So yeah, hopefully it will grow a bit more in the future.
For sure.
And well, awareness helps. So thank you for providing this info to us. It's really useful, and I really do hope that it gets some more traction in the future.
Sounds good.
Yeah, it's
Thank
really
you so
useful.
much.
Thank you too.
Bye.
Okay. So we're